Hi guys, so this sheet is going to be our review sheet for our quiz that's coming up. I know that I have not been in school, so the date has changed. As of now, I am still planning on having it due on Friday. So this review sheet is going to be up to you guys to watch this video and make sure that you know everything for the upcoming quiz. So what I'm going to go over with you guys is the three types of functions that I've briefly covered over the last week. We have absolute value, we have square root function, and the last one we worked on was piecewise. So I'm just going to go over this as like a study guide. So on these first two sheets, there is no actual math involved. I'm just going to be reading and highlighting some important key information that you need to know about each of these functions. So the very first one is the absolute value function. This is the parent function that we have right up here. Hold on. Here we go. So I'm going to highlight this. My pen wants to work. There we go. All right, so this is our parent function of the absolute value. So you recognize absolute value hopefully by the two lines here. Remember, absolute value just means the distance that a number is from 0 on the number line. And the next important thing that you have to know is what it looks like. So on a graph, absolute value, we remember the V in value because it creates a V-shaped graph, and the parent always starts in the middle at the origin. That's where the vertex is. Now we know that any function can be opening upward or opening downward, but our original parent function is positive, so it opens upward. The next thing that we talked about was the transformations, which is when we shift or change the original parent function into something different. So I know I have not shown you guys this exact formula or this form, but nothing to worry about. Just know that the H and the K are representing numbers that we could plug into those spots. So what you have to just know about H, which is the number inside of the bars, is that means it could shift it left or right. And this is the tricky part. We have to remember inside is always opposite, inside opposite. So even though we might see a minus, does not mean we're going left. So minus means right, while plus means left. Okay. K, which is on the outside, this is where we don't have to think opposite. So if our outside number is positive, we are going up. And if our outside number is negative, we are going down, just as we would assume it would. Okay, so this would be like an example right here. So the inside, our H, is a positive 2. What we might think means right actually means 2 to the left. But on the outside, that minus 3 does mean 3 units down. One additional transformation is if you see a negative on the outside. So if there was a negative here, a negative on the outside means that we're reflecting. So we're flipping it, a reflection over the X. So what would have been, a happy face V is now a sad face V. It's facing downward because it's negative. Okay? All right, just as steps to graph, because none of these graphs you have to do by hand, okay? You can do all of it on the calculator. So you know to first start by clicking y equals. That's how you get started. You type it right into your y1. You just copy it. You're going to click on graph because you want to make sure that the picture is creating the graph that you want it to be. If it's an absolute value, it should be a V shape. If you're getting something that's not a V, then you probably did something wrong. Then you're going to go to second and then graph again to get the table. We want our table of points. Now, you can choose any points that you want, but you do want to make sure you're choosing numbers that are in order. So you're not going to skip around and pick random numbers. You want to go in order, and I always suggest find the smaller numbers. Make sure your numbers are whole numbers, no fractions, no decimals, and they're all going to fit on the graph. Our graphs usually don't go past 10, so doing any number greater than 10 is kind of pointless. Okay, so that's absolute value. You know what I'm going to do actually is after I go over each one, I'm going to go straight to the bottom and we're going to do an example. So here's an example. This is what we're going to graph. Y equals the absolute value of x minus 2 plus 3. So what I'm going to do is I'm going to now move to a graphing calculator, which I found online. Okay, let's try to get this in order here. So y equals, I'm already in y equals. So what I'm going to do now is I'm going to put in that fraction. Not fraction, I'm sorry, the absolute value. So what we do is we click on math, we move over to num, and we want to make sure that first one, ABS absolute, is what we're going to click on. Now I believe on the inside we had x minus, sorry, it keeps moving, 2 on the outside, and then a plus 3 on the outside. Let me just double check that that's right. Yes, okay. So after we put it in, we're going to click graph, make sure it's correct. That should give us a V. It does. We're going to click second graph, and we're going to look at our numbers. So again, you remember you can go up or down. This scrolls. You should get some negatives. You should get some positives. There's a lot of good small numbers here. You can write as many as you want down. Okay, I'm just going to do a little screenshot of this so that I know what I'm writing down. Okay. So now I'm going to go. You should always write down. If you have a writer, you should be asking your writer to write these numbers down for you of whichever ones that you chose. So let me switch over to pen. I'm going to very quickly copy down these points. We're going to do -3.8 is good, -2.7, -1.6. This was all from the calculator. I just took a picture of it using my phone so I could copy it down. 2, 3, 3, 4, 4, 5. There's plenty more that would fit, but I'm going to start there, and I can always add more. So -3.8, we go all the way up to 8. I have -2 and then up to 7. I'm starting at the bottom here, okay, just so you know what I'm doing. You always start on your X. -1 up to 6. 0 up to 5. As you can see, it's hitting like every corner. 1 up to 4. 2 up to 3. 3. Now we're going back up again. So I had my vertex. 4 up to 5, and this would keep going. I actually can add more because I want it to be symmetrical. As you can see, I'm hitting every corner. You should connect your points. Make sure you always draw your arrows. You should have a nice V shape, and you should always label the graph. Y equals the absolute value of x minus 2 plus 3. So there you have it. That's all you have to be able to do. Know how to use your calculator, and make sure that you're accurately graphing the points with arrows and with the label. Okay, the next one was a square root function. So for a square root, this is the parent. We know what the square root symbol looks like. There it is. They throw an X underneath it, and it gives us the parent function. Okay, the graph also starts at 0, 0, very similar to the absolute value. However, this one is a curve, and it's going to kind of go upward, up and to the right. So if this was my coordinate plane here, the square root function starts here, and it looks something like this, where it's only going, as you can see, forever in one direction, which is why there's only one arrow, and that's very important. If you were to do this and add an extra arrow, they would take points off from the regions. That's incorrect. Okay, so similar transformations, just instead of the absolute value bars, they're using the square root symbol. So again, H still means the same thing. H means left or right. The K on the outside means the same thing, up or down. So in this case, if I saw -3, minus might mean left, but we think opposite, it really means right. The outside is always exactly what you think it is. If it's 2 and it's positive, we're going up. So inside is left and right, outside is up and down. Okay, same rules. You're going to click on your Y equals. You're going to type it into Y1. You're going to graph, make sure it gives you that shape, that curve you want. Second in graph will give you the table. We're again going to just be careful. You're going to notice a lot of errors. Errors mean that it doesn't exist because there are no negatives. Okay, so because you can't have a negative you can't have a negative square root. So you're going to just avoid those when you're graphing. Make sure you're picking small numbers that will fit and whole numbers only. So let's go ahead and do an example. So here we have I keep saying the same thing. The square root of x plus 1 on the inside minus 2 on the outside. So let's give that a try. I just forgot it. Plus 1 minus 2. Okay. So I'm going to clear this. Go to our Y equals again. What's going on? Clear. Okay, this time I need a square root. So for square root, you're going to click second x squared. X plus, it keeps doing that, 1. On the outside, we're going to put a minus 2. Graph. Okay, so as you can see, it's shifted from the parent because the parent starts at the origin, which is in the middle. This has shifted, as we would assume. All right, so we're going to go to second graph. So see all these errors? Yeah, we don't want those errors, so we're not going to graph any of those. So we're going to scroll down. Okay, I'm seeing a lot of decimals, which I'm going to try to avoid. Any numbers that are good, we're going to keep. So like -1, -2 is a good point, and 0, -1, and 3, 0, and 8, 1. And I don't think I can go farther than 8, so that's going to really be the only points I can use, so not too many. Did I do that right? Yes. Okay, so I'm going to very quickly write those very few points down that I was able to get. So we had -1, -2. We were able to use 0, -1, 3, 0, and 8, 1. So not too many. So -1, -2 was here. 0, -1, 3, 0, and 8, 1. So this is the starting endpoint, and it goes, connects, and this will continue with an arrow, and we're going to label. And that's it. And a question on the Regents like this might just ask what the transformation was in addition to having you graph it. So you would just say it was a shift left once and down 2. And as you can see, that's what happened, because if you start here, we went 1 left and we went down 2. It moved from its original parent endpoint. All right, last one is piecewise. So a piecewise function, remember the word piece because it's in pieces. Okay, so a piecewise function consists of different expressions for different intervals of x. The graph changes depending on the value of x, so we restrict the domain. So a couple of steps and things to remember when you're graphing them. You're going to identify the different intervals, understanding that where we're going to graph it, it depends on the restricted domain. We're going to plot the points for each part individually. We're going to draw each segment of the graph according to the intervals, and we're going to make sure that we're looking to see if we need to use open or closed circles. So here's an example. So we have two graphs, or two functions really, x plus 2 and -x plus 4. These are both linear, and they're telling us for x plus 2, they want us to restrict the domain so that x can only be numbers that are less than or equal, you have to know your symbols, less than or equal to 1. And for the next one, we're only using x's that are greater than 1 and not including it. So this would be a closed circle to start. This would be an open circle for that function. So you would just graph each one individually. You would graph the first equation alone, look for the x value, the first x value, which in our case is a 1. So you start by looking for 1, and then you're going to choose numbers that are all less than 1. That's exactly what we said, less than or equal to. And again, we're using a closed circle. For the second equation, we're going to look for that number 1 again, because that's where we're starting. That one's going to get an open circle, and then we're only going to be using numbers that are greater than it. Okay, and there should only be one arrow on each side for those two graphs because it's restricted. All right, so let's do one example and then we'll be done. So here's my example. Let me take a picture of this because I know I'm going to forget. Okay, I did teach you guys that you could put a whole piecewise in the calculator at once, but I'm going to do one at a time. So I'm going to clear it. So the first one was 2x minus 4. So we're going to put in 2x minus 4. Graph it. Should be a line. We're not drawing the whole line, obviously. We know that the restriction was x is less than 0. So 0 is our starting number, which I already happen to be on. But I want my x's to be less than 0. These x's are all greater than 0. So these are not going to work. So we have to go backwards. Backwards, backwards, backwards. Okay? Now, some of these numbers are way too big. We can only go up to 10. So I'm going to go from 0, -4, up to -3, -10. Those are going to be my first points that I'm going to use. So give me 1 second. Okay, so for that first graph, I'm going to write the points over here that I'm going to use. So we're going to do 0. Actually, I'm going to go backwards. I'm going to do -3, -10, -2, -8, -1, -6, and 0, -4. And this was the first one. At 0, let me do that. At 0, we're starting with an open circle because it's not including it. So that first point, 0, -4, which is here, is getting an open circle. Then everything else is regular. So -1, -6, regular point, -2, -8, and -3, -10. So it's only going forever in this direction. It's not going past that 0 because it's restricted. Okay, the next one we're going to do, it looks like it's a quadratic because that x squared. So y equals, clear it. I'm putting an x squared. That's the original parent function of a quadratic. Looks like normal. Okay, and then second graph. Again, starting at 0. So 0, 0 is where we're starting. But this time, my x values have to be greater than 0. So these numbers over here. So all of these numbers are good, but again, these are too big. So we're not going to go past 16. I think 0, 0, 1, 1, 2, 2, 4, and 3, 9 are all going to be perfect numbers for us to use. So I'm going to write down that I'm going to use those over here. So that was 0, 0, 1, 1, 2, 4, and 3, 9. And for this 0, we can use a closed circle. So 0, 0, 1, 1, 2, 4, and 3, 9. So it's going in this direction forever, not in the other direction forever. Okay? And I'm going to just label both of these. So this was f of x equals 2x minus 4, and this one was f of x equals x squared. And that's it. All right, so please make sure you like the video when you're done watching it so that I know that you've done it, and hopefully you guys will be ready for your quiz on Friday. All right, bye.